group GJL will explain the action potential and its diagram. So basically, the action potential is an electrical signal that travels along the membrane of a neuron or other cells as a non-gradient depolarization. So basically, non-gradient just means all or none. Okay, so I will be beginning to explain stage 1, which is resting state. So basically, for stage 1, this is the resting stage where it is the membrane potential of the membrane potential is at negative 70 millivolts. So when the axon membrane is polarized, it is negatively charged inside the axon. It is basically like this. This is the axon. So its outside is positive due to the metal ions outside of it, such as sodium ions and potassium ions. So when the voltage gated Na plus channels and voltage gated K plus ions, K plus channels are closed, the sodium potassium pump and the sodium potassium pump and the sodium channel and potassium ion channels are maintain the resting potential. So for example, this axon we have N plus channel and K plus channel. So basically, the sodium ions will diffuse into the axon down the concentration gradient, and K plus will diffuse out of the down the concentration gradient. So yeah, you guys just have to remember this. In and K out. So that's basically it for me. Thank you.
So now I will be explaining step 2 and step 3, which is depolarization and rising phase of action potential. Let's start with stage 2, which is depolarization. When the stimulus, this is resting mark, so no stimulus presents. So when stimulus presents, it will open the sodium channel, which is this. This is the sodium channel, and it will be opened. Sodium channel will be open, and then when the sodium channel open, there will be Na plus sodium ion diffused into the axon, and because the ion diffused into, so the depolarization will slightly occur. So you see this will slightly increase a bit, the graph slightly stiffer, but the voltage, the gate pair will remain closed. The K plus channel will remain closed. and so on. When the depolarization reach the threshold level here, when the depolarization reaches the threshold level, the action potential is generated, which the threshold level is about negative 55 MV in many neurons. So next is rising phase. When the depolarization level reach the threshold level, they will trigger the K+ channel to open and will become open. And when open, there will be K+ also. K+ ion will diffuse into the new neutrons. Yeah. So axon, sorry. K+ ion will diffuse into the axon, and the depolarization will occur further until the highest point at the positive 30 or 35 MV. The action potential is generated. So that's all from me.
I will be explaining Pauli's phase of action potential and Hanisu. As you can see in the graph right over here, with membrane potential it goes down after the rising phase potential. At this phase, the voltage gated of Fe+ channels is inactive, and most of the voltage gated K+ channel open, and this causes the K+ to move out of the membrane, causing it to become more negative. And number 5, Hanisu, as you can see here, it falls below the resting state. Here, most of the voltage gated K+ channel will close slowly, and excess K+ diffuse out of the axon, and inside of the axon membrane becomes more negative than the resting potential, and some of the voltage gated K+ channel will remain open.